So I said that today we will talk about the object-oriented programming in Python, and basically this is a very important step in my mind because previously we were using just like already predefined for us data structures in Python. We saw some integers, lists, etc. And at some moment we want to describe our own data structures in Python. For example, sometimes you need to identify something which is not exist in the current state in a Python, or there is a lack of some functionality, and then you can create your own data structure. But before we start working with classes, so basically the class is like the way to define your own data type, data structure in Python and add some functionality to it. We will cover namespaces and scopes in Python because before we didn't do that, and it's still important to know it. And let's create a new folder. Yeah. And in the beginning, I just want to show you like the idea of the namespaces and scopes in Python. So we remember that we can create a variable in Python, right? And then so we can assign any object that we created to this variable, and it's just as a link. So as you remember, for example, we saw examples with lists where we assigned two different variable names to the same object, and basically it's like simply as a link. It's not like a hard-coded. It doesn't mean that we create a different variables for the same object. If it's like immutable object, if we reassign something, then we just change the link to another object. Yeah, and we can think about it in the way of the dictionary as a data structure that we already saw. It's a dictionary where we have like a pair, right? We have key and value. And in our case, we can think about any object that we create in Python that the key, it's a name of the variable, and the value in this dictionary, it's object itself. And this is just as a representation that any namespace, and we will see that Python has different namespaces, can be represented in the form of the dictionary. And this is just as an example that if we create a variable x and we assign to this variable the list 1, 2, 3, then we can say that in some particular namespace we created a key value pair. We have x and the value. And basically, so right now you can ask why it's important, and in reality you will see that it gives us like some functionality because we have different namespaces, and because of that we can have the same name in different namespaces. And so this is an example of local scope. Let's just copy and paste it to our editor. I'll create like scopes.py. Okay. And this is an example. So, and if we have a function, you can see here we have indentation, right? And we will start with a local scope. Then we will go to the upper level, and then upper. So we will start from the most deeper one. Here is an example. We created a function, and as you can see, we specified the body of our function, and then you can create a new variables inside of the function, inside of the body of the function, and then they will belong to the local scope, right? let's just execute the program. It doesn't give us something interesting. So we have local variable, and local variable is a string that is saying I am local. And then we simply print the local variable value. And now, for example, if we try to get the access to this local variable outside of the scope, outside of the namespace, we will get an error. So let's just try to get the access to local variable outside of the function. So you can see that the variable was inside of the body of the function, and we can operate with this variable when we are inside of the function. But now the function is already finished its work, and we want to still get access. And you can see even my editor already highlights that something is strange happening. So if I just hover, it's saying that this variable is not defined. And if I run the program, you can see that the name error, local variable, is not defined. And this is the idea that the local scope is some scope where we have namespace for the variables, and these variables cannot be accessed outside of the scope. Yeah, guys, and as always, if something is kind of strange, just let me know. And then you can, for example, create a more complex structure where you have function, and then you can create another function which is basically specified inside of the function. So I will comment this part. Here's our new example. We have inner function and outer function. And basically, so here we have a variable which is in the first function, and we called it outer variable, and it's just I'm in the outer function. And then inside of this function we specified a new one, and we called it inner function, right? And there is another variable. And now we are trying to print both values, outer variable, inner variable. And as you can see, we call the inner function inside of the outer function, and then in a main part of our program we call outer function. So, and guys, what kind of thoughts you have? Will we get error, or will successfully print everything?
In this case, I think there's no return function, so we will get nothing. No?
I think we get the both outputs.
Both outputs. Okay, so we have two ideas, right? And basically, let's start with the first one, that we don't have return statement, right? And so it's true that we will, as a result of the function, something that it returns, we will get none. So we can check it. We can, for example, assign.
Sorry, I didn't notice that outer variable is inside of another function, so it's will be kind of error because.
Okay, yeah. So now
maybe not.
Also, yeah, another option. That's fine. That's just like as a, because it's basically what we cover right now. It's more about some rules which Python has. So it doesn't mean that you should right away know the exact answer. It's more about all of us, we have some intuition, and just like we are trying to understand, does it match the logic that Python has or not? And if it's not, then we just need to adjust it a little bit to memorize some things. Yeah, and so let's start from the first point that you said, that the function doesn't have any return statements, which is true. And this means that as a result, if we're trying, for example, to assign the result of our function call, it's indeed going to be none, and we can even check it. But we have like print functions inside of our code. That means that during our program is going line by line, it will try to print something to standard output. And if I run this program, it's gonna either crash or print something. And let's just also print the value of x. We will just check that it's none. And as you can see, so x is really none, but we didn't have any errors here. And this is a rule why it worked correctly. In reality, so yeah, we could like think about that we had like outer variable inside of the inner function, and we can think about it, yeah, why did it have access to the variable which is outside? But this is a logic of the Python. So if you have like enclosed, so for example, if you have a scope which is inside of the another one, then this scope can check the variables which are outside. And basically the idea in my mind, for example, when I try to keep it simple for myself, I think about it that you see that we call some functions here, right? And we didn't specify them inside of our inner function. And basically this is the idea that in this particular case, when we are like going from the lowest or deepest part of our function up, then we can, for example, try to at some moment reach the functions or some variables which are global, which are built in, that we can use the functionality that Python provides for us by default. Otherwise, if we would not have access to these variables, to these objects, we will not be able to use print function and all of this. Yeah. But another direction could lead us to the problems. For example, imagine that you created a function, right? And you created a variable x there inside. And then if you somehow used it somewhere else without, I don't know, without assigning something, then it can lead to problem that this variable was inside of some function and you kind of forgot about it or something like that. And yeah, basically it can lead to some problem. Even this approach, which Python has, sometimes can lead to some issues, but it's more understandable probably. Yeah, let's check now global scope. So as you saw, for now we have local scope. Also we have enclosing scope. This is like something which is like one level upper of the local scope that we have. So in this case, in my mind, local scope is a relative thing. You can think about it that this is a local scope, and then everything which is here, it's a enclosing scope. I will just comment this part. And in reality, we have a global scope. So as you can see here, I created a variable on a top level. We don't have any function, we don't have anything. And basically in this case, this is a variable which is created in a global scope. It's not a part of the function. And so in the beginning, I showed you the indentation, but indentation not always the case. For example, if you using the conditional statements, you can also create variables inside of the conditional statements. But if they were in the global scope, then the variables will be also in a global scope. So for conditional statements, it doesn't like work, and for loops with context managers, as you remember, we can use the context manager to create files and then don't think about, don't remember like, and don't keep it in mind to close them in the end. So context managers will automatically close the files, but we can still use the variable that was used there later on. And this is a global scope. And with global scope, you can see that we have a function. We didn't specify any variable inside of the function, but we have the access to global variable in reality. Yeah, let's just check it. So I run it. You can see, so if the variable in a global scope, then we can get the access from the local parts of our function program, which is also you should keep in mind, because in reality, what is interesting, you can create the variable with the same name inside of the function, right? And let's assign something here. So now I'm not global anymore. And so guys, what kind of ideas you have? What's gonna be the output in this particular case? Again, it's just kind of.
I think that for first function we will have now I'm not global anymore.
Okay.
For second, we still have I'm global.
Yeah, I think so. And why do you think in this way?
Because global variable does not change in the function.
Okay, yeah, that's
Yes, it's change only in function, but not global.
okay. Let's check. So, and you're right, yeah, because when we have this statement here, in reality, we created a new variable in the local scope, and we had another variable which was defined before in the global scope, but now in local scope we created a new variable with the same name, and it doesn't have any problems. So in this case, when we see this statement, we will just try to find this variable in the current namespace, which is a local, and we will find it. Yeah, but when we don't have it inside of the function, in this particular case, Python will try to find it in the local scope, and then Python will see that there is no such variable in the local scope, and because of that, it decides to try to find it in particular order. So we will see it basically the order called LEGB rule, and this is how Python operates, how it tries to find the variables. And this is so here I tried to represent the full idea of it. Yeah, sorry guys, I forgot to say you that there is a built-in scope. And basically, because of that, we have access to all these functions, like a length, we can use sum function, print, and all other things, which usually we didn't specify, but somehow we could utilize it in our programs. And as you can see, for each program that we write, built-in, it's like the most upper or like the most top scope that we have. Then we have a global scope. You can think about it as a file, and then you have like you can have some statements inside of the your program on a global level, which is not inside of any function for now. Then you can specify function. You have enclosing scope, which is starts before the inner function. And in reality, you can have like a very complex structure of functions. There can be multiple inner functions without any problem. And this is if you right now here, it's going to be the local scope. And the rule in which Python travels through all the scopes to find the particular variable that you're trying to, for example, use, we start from the local scope, and then we try to find it there. Then we go to the enclosing, then to the global, and then to the built-in. And in this particular case that I showed you, we started from the local one. We saw that there is no particular variable, and because of that we went to the next one, and in our case the next one was a global scope because we didn't have enclosing scope. And this is just as a representation. And in my mind, it's like very similar to the life, because for example, you can have the same type of the objects in your house, right? Let's say that you're in your room, and imagine that in your room you don't have a TV there, right? And you want to find the TV, and then you will just travel through the all rooms that you have. And let's imagine that you have like a very weird shaped house. You have like just like the rooms are like as a sequence, right? They are not so it's not a square where you have like interconnections between different rooms. You have like just as a sequence of rooms, like let's say like a tunnel. You have your house is like a tunnel, and then you have like rooms there. And the first one is like your personal room. Then there is, I don't know, like a living room or like office. Yeah, and then you can try to find the objects. And you can see the TV is like in the particular room. Also, what is interesting that some objects, you can see that we have chair here, right? And also we have chair in the next one. And if we try to find chair, first thing that we trying to do, we will try to find chair in the current room that we are in right now. So guys, I tried like my best with scopes. I hope that it's a little bit more clear. It's supposed to be definitely more clear because before you didn't see it, right? So I think that anyway it's supposed to help. Okay, and
So the object that we search for is a variable, and the room is like a function or external function or something like this, yeah?
Yeah. Like a function, also we will see that the classes also have their own scopes. Yeah, but functions.
Understand.
Yeah, and we can get the representation of the namespaces, or also I call them scopes. Basically, in my mind, somehow it's like messed up, but the idea is similar. So we can check the namespaces by using the built-in functions in Python. So, and in this case, let's check it. I'll call it a new way. So it's like name spaces interaction. I don't know. Let's call it in this way. Yeah, and I'll just copy and paste the example that I have. In reality, we can get all the whole namespace by using the globals function. In this particular case, we will get the global namespace. And as you can guess, we will have key value pairs for this particular case. And definitely there is, so we have expectation that global variable will be in the global namespace. And as you can see, in reality, we have a lot of different things in the global scope, even something that we didn't specify. So we have the name, we have the name is main. As you remember, when we were looking on the modules, we used it. We was writing if name is equal to main, then we want to execute some specific statements. Otherwise, we don't want to do anything. And in reality, so you can see that we have a lot of different other things. But for us, what is important that we have our global variable as a part of global scope. And then we can adjust it. So we can comment this part, and let's just create a new function. And this is just, okay, namespace, or like show namespaces. And then we can create a local variable. So local variable is, let's just call it very transparent. So this is a local variable string. And then we can print the locals. And let's call it show namespaces. And now if I execute it, you can see so that in the local scope, in the local namespace, there is just one variable, right? As expected. And basically, so we don't have enclosing or something like that, because I said it once today that the local scope, it's a relative thing. So local is always something where you are right now. Even we can try to check it, for example, I don't know, to be honest, I don't remember, did I try it or not? If we print locals inside of the global scope, so my guess, yeah, and it's like correct, that we will get just a representation of the current local scope. Namespaces will be fetched from the global namespace because it's a relative thing. And because of that, we don't have some enclosing or something like that. We just can we can just get everything by using locals. Okay. And built-in, guys, built-in, which is very important. So built-in, you can even find it here, so that we have built-ins, and this is a module which is called built-ins, right? And because of that, we have access to the variables. Let's just also, I want to show you that there is a function called dir. And this function gives us just the names of the scope. You can see, so we got all these names by using the dir function. If we have the show namespaces, right? Let's then print dir of show namespaces. And then you can see that for each function, in reality, we have a lot of different things which we even didn't specify. And we will find out why we have all these things right in the moment when we start working with the classes. Yeah, but also in reality, so you can try to work around and, for example, print the built-ins. Just to check what it is. It's gonna say us that it's that this is a module, but then if we try to use it with dir of built-ins, you can see that we have a lot of things inside of the built-ins. And basically we got all names which associated with the built-ins. I mean, like, built-ins is a module, right? And then inside of this module we have a lot of different things. And this is an example that we have a lot of so basically it's exceptions, also errors. Then we have, for example, the len function, we can use the power function, we can open something, string, etc. So all these things that we used along the whole way that we already made, they were inside of the built-in, and because of that we could have the access to them. Yeah. And in case if we create a new function, not function, let's create a new file, let's call it custom module.py. And I want, like, as the same way as we did before, let's put some things here. So for example, def, I don't know, custom apps of x, return x if x is greater or equal than 0, else minus x. And then def custom sum, something very simple, and return x plus y. Now if I import it in my namespace interactions, import custom module, then again I can check what kind of functions are inside of the module. And you can see that we have custom apps and custom sum. Also we have some other predefined things by default. Yeah, because so we can check name. If it was a package, you can check this package, all these things. So guys, is it clear? let's say yes, right? Or no?
Yes.
Yes.
Nice. Okay, that's very cool. Okay, and now the very important part. So we started this course in the way that I showed you, for example, variables. I said that variables is very cool because it helps us to reuse some parts of the code. We don't need like to specify the value or like just copy and paste the value over and over again. Then at some moment we faced with functions. We're like, okay, functions. Now we can create very complex things. We can reutilize some code snippets when we see that we use them over and over again. Then we saw files that we can create our own modules in Python. And now the next step, it's classes. And it's also, in my mind, belong to the same category. That this is a new functionality in Python, which allow us to specify some code that we can later on reuse and reutilize. And basically, let's start. So probably at some moment I should adjust it and make it like a class for some particular biological stuff. But in this case, we will work with the cars, right? Like a car where you can sit and drive wherever you want. You know, if be honest, before I didn't appreciate cars in general. I'm like, okay, car, who cares? But at some moment I realized that the car is like it's nice to have it. Yeah. And today we will try to just mimic some very simple in the model description or like implementation for cars. And let's start. So I'll call it cars.py, or even let's call it from the capital letter car, you know, just to emphasize the importance of it. Yeah, and I will just, for now, like I'll slow down, I'll just type. I could copy and paste, but let's just do it in this way. So we want to specify right now a new data type, and then it allows us to generate a representation of cars. And let's for now just fix some particular things. So this first argument we will cover. Usually for me somehow it's hard to explain, but I'll try my best. I'll try my best to explain it. And for now let's just think that there is some first argument which we called self somehow, I don't know. And then after that, there are like more understandable things for us. So let's say that each car has a brand and we want to keep it in our data type. So brand, model, for example, we want to have also the year when the car was released, color, and let's say that we want to have the fuel level. So we have a odometer, which is saying how many miles we already passed. Okay, and let's check that we can have some Boolean data type here. So, and as you can see, this is very similar as a function. So we have a function inside of the car class, and this is just as a syntax. So to specify a new class, we write class, then there is a name, and then column symbol. And the rule usually that we want to start the name of the class with a capital letter, because then it's you can distinguish. So for example, if there is something which starts from the letter in lowercase, probably it's either function, either variable. But if you see that there is something which starts from the capital letter, usually it's a name of the class. I mean, like if people follow this notation. And now what we want to do, this is a initializer. So this is a function which gonna initialize the object of our class. And inside of this function, we need to say what kind of features we want to initialize. In reality, so you can think about it that all this information is gone. You don't have anything, right? But even in this case, you can initialize your object with some particular things. Maybe with some features which are relative to any car or something like that. And now I will write the statement, so self, and then there is a trick. So I will use a self brand is equal to brand. And this part probably not very clear, but I think that in the moment when we're gonna start interacting with our object, I hope that you will understand everything. So, and now I just need to put everything. So basically how it works. Self, in this case, it's an object that we created. You can think about it that the car is a factory, and car factory produces or creates a new cars. And right now we are on a factory, and we got like some description of the car that we want to create. And self, it's like as a template of the car. It's a template, and we want to add all these features that were specified for us in the init arguments. We want to assign it to our particular object. So to do this, we put self, and then after the dot, we can specify the attribute that we want to add to the car. And so the color is color, and then self fuel is equal to fuel, self odometer is equal to odometer, and self doors locked is equal to doors locked. In reality, you can use some other names here. This is arbitrary. This one is just on the right side. Why I used these names? Because they are just like function argument names. But this one you can put in any way. I just want to make them exactly the same as a function argument. Okay, and this is what we did. Now let's create a car. So this is a very simple data type that we specified, and now we can create a new car. So to do this, right, we need to create it and assign it to the variable. You can just create it without assigning, but I want to create and assign it. So let's say that we want to create a new object of this class, and I want to get some kind of representation of the Camry car. And to do this, we need to call car as a function. So you can see I called car, then we have the brackets, and inside of the parentheses, I need to put the arguments. So let's say that the brand is Toyota, right? Then the model is Camry, and then we have that the year is 2024, for example, very brand new car. And then we need to put all these arguments as we had them here. In reality, you can just put them as a positional arguments, as it was for functions. Here I just specify very explicitly that we have color is red. Let's say that the fuel is equal to 0 because it's a brand new car, just like from the saloon, right? Or from the dealership. Then we have no, it's opposite. It's fully packed with the fuel, but odometer is 0. So this car didn't make any move yet. Odometer and doors locked, let's say the true. And we created the object, right? Now we can just print all these arguments. So now we can print, for example, Camry, and we can get the access to any features of our car by using the dot, and we need to specify the name of the attribute that we want to get, for example, brand. And let's make it so brand is Camry brand, and then model is Camry model. So, and you can see that we created a new data type with a custom functionality. And now you can, for example, utilize it anywhere, right? Let's also create one more car. As an example, let's create a Tesla X. And in reality, we can specify some default values here. So let's say that by default, we want to have that all these arguments are, so doors are locked. And in this case, we don't need to specify everything. We just need to specify brand, model, year, and color. And then in the same case, in the same way, we can print the attributes of our new car. So, and as you can see, when we called the car, we didn't use any self, because self it's an internal argument, and self corresponds to the object itself. So in this case, when we call car or something like that, there is gonna be process of creation of the template, and this template will be called in our case as a self. You can put here also arbitrary name, but very common is to use the self. I believe I had even the some visualization of the process. Sorry. Okay, so about the init method, and this is like some explanation about the self. Yeah, so you can think about the self as like a template of the object. It's like as a entity which didn't get all new features yet. And then you can add a lot of different features to this template, and it will specify your object. And usually we put it in the most first place. So you can see that the self, it goes the first, and this is a template that we will operate on and change all these attributes. Yeah, and in this case, so you can see that there is like explanation that Python automatically passes Camry as a self. So it thinks that the Camry, it's self, and then for this self we assign all the features. And this is just as an example. So we had self, then we got some features, and then these features like built up our object. And in this particular case, we have a Toyota Camry. Yeah, and this is also the explanation that you can consider the init method like the birthplace of an object in Python. And at the beginning of this method, self is like an empty canvas or like a template, and then we form our object as we're going through the init method. So guys, okay, what do you think? Let's discuss it about self. So because it's like sometimes a little bit tricky, but the idea is that in the method, so this is the method of the class, usually self, so particularly in init, we can think about it as a blank canvas, and then we, for example, paint something. We specify the object inside of the init. But later on we will see some other methods, and also self will be there. And self then gonna be as a link to the object itself. And I'll show it to you. But for this particular case, if you have any questions, then please guys, ask them.
I have a strange question because the classes reminds me something like dictionaries. So if there are any instruments or tools that we were discussed in the previous lesson that can replace the class function, something like what we can use instead of this.
So instead of this, in reality, you can use just functions, for example, right? You can say, but in this case, somehow it's a little bit trickier and a little bit harder in particular cases, because usually the idea of class is that there is a particular object and there is a functionality which is assigned to it. And in reality, yeah, you can, for example, perform everything by using just functions or something like that, but the code itself gonna be more bulky in my mind, so it's gonna be kind of not so elegant. And in reality, so there are some other things which you can utilize. So for example, there is a thing which is called, let's go to google.com, and there is a, I believe it's a named tuple. But you can just find some other things, or even you can, like, yeah, you can, as you said, for example, you can think that you have a dictionary with the key value pairs, and this is a, for example, brand, something like that, and then in your function that you're gonna specify, you will operate with such dictionaries, right? But in this case, you need always to create them. Yeah, you can, for example, specify the function outside of it which gonna create the dictionary, right? So you can say that, okay, for example, you can call the function is like create a car and then pass all these arguments, and as a return statement you can return the dictionary. And then, yeah, you have like all these cars, but we will see what is, in my mind, the most beautiful feature of the classes. Because, for example, in this particular case, you will have all these functions outside and you need always to call them. But with the classes, all these functions always bind to the objects. And because of that, we can use this functionality easier, in my mind.
Yeah, thank you for your answer. And another one question, maybe a stupid one. Speaking about self, is it a constant word? Can I replace it for something else, like car, for example?
Yeah, you can replace it without any problem. Yeah, let's do it in a very way. Okay, so yeah, we can replace it, but so Python just knows that the first argument supposed to be, something which is associated with the self. And then if we run it, so everything works correctly, you can use the name that you like, but you will see that usually if you, for example, looking in the documentation of other programs, of other like packages, people try to stick with the self, because then everyone knows that, okay, self itself. Yeah, because for example, in this particular case, if I see it right away, I would imagine that the person forgot to put self. My first idea is like, okay, maybe a person forgot to put self, but then, okay, I see that there is a assigning happening here. I'm like, okay, yeah, person didn't forget self, but just uses another name. Yeah.
Thank you.
Yeah, and this is just so you can take a look on the name tuple, but tuple is a mutable object, as you remember. But sometimes you can have names for the tuple. So, for example, here we create a name tuple student, and here are the names that we can utilize. So you can see that we have Nandini 19. Date of birth is 1997. Okay, this is hard to parse. Yeah, and then you can just use it kind of in the same way as a class by using the name of the attribute. Yeah. Okay, so this was about the how it's called, about the process of generation of our tuple. But now we can add the functionality, my favorite part. So let's add it. I'll just copy and paste because there are like a lot of things there. So now we can omit this part and we can omit this part. Let's just specify a new function and we call it like a vehicle status. And you can see that we have here just self. We don't have any arguments, just self. And this is a method which gonna print us the whole status of the car. You can see that this is a formatted output, which is a car status, and then we print the brand, model, year, color, fuel level, odometer. And in this case now we don't need to print it like manually over and over again. Let's just use it with the Camry. And to use the method, in reality we already saw it. So to use the method we need like to put a dot and then just specify the name and use the brackets here because this is as a function. So method is a function which is assigned to the model, not to the model but to the object. Okay, and yeah, and let's just execute it, right? So, and now you can see that we have a car status for our Camry, and brand is Toyota, model is a Camry, year, color, fuel level, odometer, doors. Everything is like here. And we just added a new method to our class. And then you can add more and more functions, more and more methods to your program. So for example, unlock, right? And in this case, you can see, so if doors are locked, we swap the self doors locked of particular car to another value. And then if it's already unlocked, we just print that doors are already unlocked. So we don't need to do anything. So let's just execute it. So unlock. And then let's get a vehicle status again. Or even maybe in this particular case, I want to just print Camry doors locked, just to get the status of it. And then again. So you can see in the beginning when we print the status of our doors, they were locked. Then we called the function unlock and we unlocked our car. And now if we try to do it one more time, you see that the doors are already unlocked. In reality, so let's specify a new function and let's call it like change door status self. And in reality, we can pass a status here. So let's say that by default, we want to keep them locked. And here I just want to self doors locked and replace it by the status that is given to us. And as you can see, I don't return anything in this method. I just want to change the internal features of the object. And then we can use this function, this method, change door status, and then, for example, I want to change it and say that the doors are not locked. So you see that they were locked and then they unlocked. And this is an example that you can pass arguments to your method. And again, so self in this particular case assigned or kind of refer to the object itself with which object the method was called. And in this particular case, we called the method with the Camry object. And because of that, we know that self, it's this Camry, and we will change the internal attribute of this particular object. Yeah, and there is also a function which is reversed for unlock. It's just lock. You can also add it. Yeah. Yeah, guys, I made a picture, so just want to share it with you because, you know, I spent some time. So this is an example that you can think about it, that the class is a factory, right? And then the class creates objects. Also, you can find in some literature that it also can be called instances. And so our class can generate all these cars. And this is just as a visual representation. And now I want to show you the shareable class attributes. This is the same attributes which will be shared with all instances. And in my mind, so it's usually, for example, there are some caveats. You can just read about them, because in my particular case, I'm not like heavily working with classes. Sometimes I know that, yeah, I want to specify my class, but in reality, so for example, Polina, as you said, I feel myself very comfortable with functions. Usually I can like implement everything with functions, and in reality, in most cases, I can just import some things from another modules without any problem. So I can import some particular data types that are that I miss in my program, and then just like make some functions to wrap them and to get some extra functionality if I need it. But sometimes we want to create a class, and we can specify something which is gonna be shared with all our instances, with all objects. And let's just put it here. So, and in this case, we need to specify it not inside of the init method, not inside of any other method, but just put it as a variable of this namespace, of the car namespace. And then we will be able to get the access. So as you can see, I just put it the location of the factory. Let's say that for each car, we know that it was produced or manufactured in a particular factory, and this is the location of this factory. And now for each car that we created, I probably gonna remove this part just like to make it simpler. Now you can see that the print Camry factory location, and then also Tesla X, that we got the access to the shared attribute. And to specify it, we just put it as a variable inside of our class, not inside of the init method. It's like just something that any object can access. Okay. And now let's talk about magic methods. The naming is very interesting, but they really can add magic to your program. Okay, and now let's say that we are working on a website. So we are building a website and we wanna sell cars. You know, you can like buy a car with some price, right? And then you can just can try to sell it with increased price. So, and then you gain some interest out of it. And let's say that we have a website for it, right? And guys, so have you ever tried to buy a car? Question for you.
Unfortunately, no.
Okay. That's not a problem. Okay, but have you tried to buy anything? For example, are you going to Ozon or some other like website? Have you tried to buy something there?
Yeah, sure. And I remember that one guy explained me object-oriented programming on the example of cards on marketplace.
Nice, you see, nice, very nice. Yeah, so this is yeah, and basically, so right now I want just to highlight some particular thing that we want to add to our class, and I just want to refer to the marketplace. Let's say that marketplace. Okay, guys, and what kind of features you usually use there on the market? So, for example, you're like, okay, I want to buy something, and you like open the, I don't know, Wildberries, Ozon, or like Amazon, or whatever, and you're like, what usually you do?
Check for the price, check for the size, for example, if it's clothes, and maybe checking for the features like color.
Okay, yeah.
And see the pictures of
Pictures, yeah, right, pictures. That's everything.
and feedbacks from other.
Yeah, right. So I'm gonna share with you like one point from myself that we're gonna try to implement. It's a very simple thing, but still. So sometimes, for example, when I'm like, okay, I wanna buy, I don't know, some crazy stuff, like a pen. Like I'm like, okay, I want a particular pen of the particular brand, and then I'm like, okay, now I assume that I filtered out all non-relevant options, and I know that they're like just the same object there. And then I usually want to kind of sort the objects by the price. And we want to sort our cars by the price. Or not by the cars, but let's do it by the, yeah, so as an example, by the horsepower. So for the car, so you usually like if you like wanna, participate in race, you're like, okay, my car should be like very powerful, and we want to sort cars by the horsepower. And in reality, if you go to any website which allow you to buy a car, then you can sort all the cars without any like model limitation or something like that, just by the horsepower. And to do this, I will remove all unnecessary part, just like to make it more clear. And yeah, I will just even copy and paste the full example that I have. So basically it's same class car. We just remove all redundant thing for this particular case, and we added a new attribute which is called like horsepower. And then we created a Camry car, Tesla car, and now to be able to sort things, we need to be able to compare them. We need to be able to say that, yeah, this car is less or equal or something like that than the other one. And let's just try. So I just want to check that Camry is less than Tesla X. And yeah. So guys, our expectation, is it gonna work?
No?
Yes, maybe.
Yes, maybe, no. Yeah. Let's just check. Okay. So, and unfortunately for us, it doesn't work, because you can see that it's like a type error, and the operator less not supported between instances of car and car. And to deal with that, there are the methods which call somehow magical methods. And basically the idea that they allow us to add new functionality to the to the methods. So, and for this particular case, we need to, so, give me a second. Yeah, there is a, in reality, so I will show you a little bit later, that there is a list of all magical methods, and if you want to add some particular functionality to your class, then you can just go over it, check it, and then add it to your program. So in this case, we want to use the LT, which is like less than, it's like just a short abbreviation. And in this case, we know that we have two arguments, the self and the another object. And in this case, we want to return that the self horsepower is less than other horsepower. You can see that it's it didn't after suggest me options for other, because in reality other could be not just the object of the same class, it can be any object. For example, you can say that I created a new class and I want to be able to compare it with the object of the same class, but I want, like, for example, to compare it with the integers, with the float numbers, because imagine that you created a class for some particular type of numbers. So in math, you can find out that there are a lot of different spaces of different like numbers or something like that, and then you can just want to add some functionality to be able also to compare with the regular real numbers or something like that. Yeah, and basically what we did, we specified a new method which gonna give us opportunity to compare. And as you can see now that the result is true, because Camry has less horsepower than the Tesla X. Yeah. And now, so yeah, let's just copy and paste this. And this is a more like nice example. So here, everything the same, just we printed it in a more nicer way. So Camry has higher power rather Tesla, and it's not true. Okay, now what is cool, that now you can even sort the values, really accomplish the task that we wanted. So okay, so now we have three cars. So we have Camry, Tesla X, and Nissan GT-R, which is a very nice car, but still, you see, like, less horsepower than Tesla. Such a sad story. Okay, and now let's run the program. And okay, so we did something, but the output is very ugly, right? So what do you think about this output? So are you gonna give it a like or dislike?
You mean, will it work?
No, I mean, like, so it's already worked, so we got some result, so it's already sorted something, but so this is the result that we got. So what do you think? Is it a nice result? Just like how it
That's not nice.
Not for human.
Yeah, not for human, so dislike, right? And in this particular case, we need to add a new method. We will add a new magical method to make it more human readable, like for humans, not for machines, right? Because right now, so what it does, basically by default, Python has a way to convert the object to the string or to the, like, to represent it. And by default, it does it in this way. So it's saying that we have a main file. So this is basically our file. And then we have a class car, and we have object of this class at particular spot in the memory, which is like, okay, for machine probably it's like very nice, to know where it is, but I want to see some reasonable thing. And in this case, let's just implement the function which is called, it's like stands for representation. We will put here just the self argument, and I want to return back the brand, like self brand, and the model, self model. And that's it. So let's run it one more time. And now, nice, we got it. So now we see that the first car in a sorted list is a Toyota, because it has like just 210 horsepower. Then there is a Nissan GTR, and then Tesla Model X. So basically we did it. We
And
did.
how the function understands that that it must be sorted by horsepower. Now, in
Yeah, how it knows? So basically, by default, sorted or sort, if it's a method, right? What it tries to do, so you have, for example, all your elements. And we know that, so there is a case, there is a thing. By default, sort tries to sort elements in the increasing order. And in reality, to accomplish this task, so for example, if you try to implement some sorting algorithms, like I don't know, bubble sort, which is like very simple. I mean, simple in terms of the how it works, right? You need just to be able to compare that the one element is less than another one. And so in this particular case, you can think about it that we try to check A1 is less than A2. And if it's true, okay, then A1 will be on its spot, right? Then A2 is less than A3. Let's say that it's not true, we will swap it. And so, I mean, kind of, there are like a lot of different algorithms for sorting, but in reality, so if you want like to sort them in increasing order, you just need to be able to compare any two elements from the list or any iterable object. And in reality, so we did it, we implemented it here. So we implemented, so this is allows us to use syntax like self is less than other. So basically this is what it does. Basically there is people call it like a syntax sugar or something like that, that you can specify this method and then it allows you to use this nice syntax.
okay, but I mean that why it doesn't use the lexicographic order? Why sort is known that we have the numeric variables here?
Yeah, because why it's not using the strings, right? Because
Yeah.
here we have the object. For example, we have like three objects: Tesla X, Camry, and Nissan GTR. And for each object, we have a lot of attributes. So we have brand, model, year, color, and in reality, you can use. So you can specify how you want to compare the object yourself. But here we specified that we want to compare objects of the class car by using the horsepower. So we just explicitly saying it here that if we want to compare objects, we want to use just horsepower, nothing else. And because of that, when Python sees that there is a list of cars, so we have Tesla X, Camry, Nissan GTR, and then we need to compare, is Tesla X is less than Camry? Because we specified this method, it knows that we want to compare them by the horsepower, which is since we assigned the integer values here, it will just compare them as the integers. But if you want, for example, to sort them in a lexicographical order, right? You can just write that I want to compare self, for example, model less than other model. Rewrite your, rerun the program, and now you can see that the brand is, the model is Camry, Nissan GTR, so result is the same. Okay, and if it's like brand, result is the same because indeed, so Camry is less than GTR and in lexicographical order, and GTR is less than X. Okay, but now if we sort them by brand in lexicographical order, the first one is Nissan, then Tesla, and then Toyota, which is correct, right? And so you can see that the order now is changed. Basically, we just kind of worked around the LT.
I understand now. Thank you.
Yeah, welcome. Okay, guys. So if you have any questions, let's work on them. Then let's make a short break. I don't know, like 10 minutes. I need to get some water because I'm dying, and then we will continue. Right? So yeah, if you have,
I have a question.
yeah.
Are these internal functions like LT, wrapper written on Python too, or they written on another language?
Could you elaborate a little bit?
What? Do you hear me?
Yeah.
Should I repeat my question?
So yeah, I mean, I heard your question. So you said that is this like internal function, or are they like implemented in another language, right?
Yeah, I want because I know that that functions that are used, for example, in Python, they are already written, and sometimes can they be written not in Python? Like for example, model sys, it's written in CC, as I know, or I'm mistaken. Yeah.
So in reality, Python. So there are like different implementations of Python. If be honest, so there is a implementation where almost everything is written using the C language, as you said. There is implementation which is like written. So I mean, the majority of the functions gonna be written in Java. There is like some other probably. By default, I believe that we are using the version which is mostly everything is written in C. Maybe something right now is like shifted to a new languages such as Rust or something like that. And that means that the basic components are indeed their implementation is written in C. And why it's done in this way? Because C is more efficient in terms of some tasks. It's kind of more faster. And then we usually write it in Python, and our program already in Python. I mean, some things will be executed by using the C parts, but if we have, for example, a loop, then it's gonna be a Python loop, not a C loop. In reality, there is a case if you want to somehow convert the piece of the code that you wrote and make it more efficient. For example, in this case, you need to compile your program. You need to compile the piece of the code to make it faster, because in Python so we interpret each statement line by line, and we don't have a compilation in the process. But there is a thing that you can, if you are curious, you can read about. I believe it's called. I know that definitely you can do it. Compile NumPy code. So, for example, if you are working with NumPy, there is a. I always forget how it's like. So probably it's. Yeah, so there is a thing which is called like Numba, and it can use you can see, so JIT compiler that translates a subset of Python and NumPy code into fast machine code. So, and there is a way how you can just play around it. So, for example, you can write the same function just in simple Python. So basically it's going to be the same, but you will not have this wrapper in the beginning. So basically it's called like a decorator. I hope that we will have time to look on the decorators. But yeah, so this is the point here. If you want like to learn more, you probably should take a look on the Numba. Just try a couple examples and then benchmark the result, how fast the implementation is. But it's not always the case. For some things, you will not get you will not gain like a you will not speed up a lot the program. It's mostly usually you need to know in advance which parts you can optimize and which are gonna be the same. Because, for example, if you have a NumPy package and you're like working with numerical arithmetic, then there already everything is written in C. When you kind of execute some methods from the package, it's gonna be very fast from the beginning. The problem is that if you have, for example, the loop that you wrote in Python, then yeah, it can like lead to the case where you are not super fast.
Thank you.
You're welcome. So okay, yeah, and about magical methods, because I didn't cover all of them, so there is a website which is called like Real Python. You can find any other source as well. This one I like because they always have some nice picture in the beginning. I like pictures, so yeah, because of that I'm toward them. And here they explain what kind of things magic methods can give us. So you can see leverage the power in your classes. And then everything which starts with double underscore supposed to be a magic method. Yeah, and here they're showing that, for example, init. Yeah, let's do like, for example. Yeah, for example, we can overload and utilize custom operators. For example, you can get or add the functionality to be able to sum up some variables, not variables, objects. Yeah, and if you want like to add an extra feature to add objects, you need to add the add. That's fun, right? Then if you want like to have this operator, you can add sub and so on. Yeah. So when there are like a lot of them, you can just take a look. So okay guys, let's do a short break, 10 minutes. And so for you it's 9 plus 9, it's 18:30 right now, right? So let's meet at 18:40.
Yes, okay.